This is an introduction to types of slopes of linear equations. Now, when you get into graphing, it's really important just to get a sense of, before you even start to graph stuff or writing equations, is like looking at something and being able to see if it's reasonable or not. So one of the ways in which to kind of quickly assess if your answer is reasonable is to understand the type of slope. So we always read in the English language is we read a book from left to right, and you're going to read your slope from left to right. So I can see from the left to the right, this line has gone up. And so this is considered a positive slope. So when you're graphing stuff, and you'll learn, we started to talk a little bit just about this format of y equals mx plus b, where b is the slope, where m is the slope and b is the y-intercept. So for a problem like this, the first thing I want to just say is like, this is slope is positive. When I put in my y equals mx plus b, I know that that's going to be a positive number, and we talked a little bit about these slope triangles. So your change in y to find the slope is the change in y over the change in x, or as some people say, rise over run, which makes a little less sense when you go down for rising. So we have a slope of 1, change in y over change in x, 1. So the slope is 1. So in this equation, we would write y equals mx, where m is 1, and the b is your y-intercept, which is also a value of 1 there. You can also just write this as y equals x plus 1. That's the more standard way. But the main thing is looking at that and going, okay, that is a positive slope. On this next problem over here, once again, we're reading like a book from left to right, and from left to right, this has gone down, so this is a negative slope. So when I'm looking at this y equals mx plus b format, this is going to have a negative value there, okay? Or if you have a negative value there, when you go to graph it, it better be going downwards. So this is negative 1x plus 1, and we'll get more into how to actually get those formulas later, but this is just an intro into slopes here. Now, you're also going to you should also be aware of these two cases here where we have a horizontal line. Okay, I'm thinking about the horizon, so like the sun on the horizon. Okay, so that helps you remember that that's a horizontal line. And once again, if we write down our equation, y equals mx plus b, and you pick 2 points and you try to do your change in y. So once again, m equals the change in y over the change in x. Like, how much did this rise? Well, it didn't rise anything. It's 0 over 2. And so in this case, your slope is 0. So your m is 0. So we're going to substitute that into our equation. So we have y equals 0x plus our y-intercept is 1. So you could leave it like that, but typically when you have a 0 for a coefficient, coefficients being the numbers in front, you would just not write that. So y equals 1. Now, another way to think about this is if you were to plot points, if you were to go back and just plot points. So this is the point 0 in the x direction, 1 in the y direction. Here's the point 2 in the x direction, 1 in the y direction. I could pick a point here. This is negative 2 in the x direction, 1 in the y direction. And I made just a table with these values. What an equation for a line does, whether it's this equation, it tells you, or this one down here, it tells you where all the points are. So if I plug in a number like 0, I'm going to get out 1. If I plug in a number like 1, I'm going to get out 2. And so it tells you where all the points are that make up that line. In this special case of a horizontal line, what are we noticing? We're noticing that every single time Okay, every single time, y is 1. Well, what does y is 1? If you wrote that mathematically, y is, or y is equal to 1. So that is what is defining this line. That's where it's going to tell you where every single point. So it doesn't matter what if I put in 4, y is 1. So that would be a point as well that would fit on that graph. In fact, I can just double check. 1, 2, 3, 4, 1, right there. Okay? So horizontal lines have a slope of 0, and they're going to just be equal to whatever the y value is. Now, let's look at the other case here of a vertical line. Okay? And this here is not a function. Okay? We talked about the vertical line test is your test for whether it's a function. A vertical line definitely does not pass the vertical line test. So this equation of y equals mx plus b doesn't make sense because, and we'll see why in a second, which is if I went to go find my slope and I did the change in y over the change in x and I picked 2 points, how much does it change in the y direction between those 2 points? Like 2. But in the x direction, 0, and we know that we cannot divide by 0, so this is so I'm going to write it down a little bit below here. So this is undefined. So it has an undefined slope. And once again, you can't take that undefined and then stick it in for your m value there. You can't go y equals undefined x plus b. It doesn't make any sense. But we can write an equation for this line. So what I would recommend, and this is just a good strategy, is pick your points, pick a couple points. So this is the point 1, 1. Here's the point 1, 3. I'm going to pick another point down here. Here's the point 1, negative 2. If I made a table here and I just wrote those values in, we can see that what is defining this line? What's defining this line is that x is always 1. And the equation for this line is x equals 1. Now, so once again, what I want you to be able to do is be able to look at a graph and instantly know whether it's horizontal, which would have a slope of 0, vertical, which would have an undefined slope, and then would have an equation something similar to this. And same thing, being able to look to see if your answer makes sense. If it's got a negative slope, you would have a negative in there for this part. If it's a positive slope, you'd have a positive value in for there. So we'll be doing lots of practice.